Okay, for question number 4, two-dimensional plane, A represents a rotation of 30 degrees counterclockwise. Here's our matrix for A. B represents a reflection over the line y equals x, so x and y trade places. This is B. And finally, C is a rotation of 60 degrees counterclockwise, and we have matrix C. So we have these 3 matrices. Now, for part B, it says transformations A, B, and C are applied to point xy successively. And the product can produce the image 1 plus 2 radical 3, 2 minus radical 3. So this is our x, this is our y. Use inverse operations to find the original xy. So when they say successively, here's what's really happening. First, they did A to the point xy. And we get xy, x1, y1. Then they did B to x1, y1 to get x2, y2. Then they did C to x2, y2 to get this point right here. So notice the only difference in my point here and what we have right down here is the commutative property. This says 1 plus 2 radical 3. This says 2 radical 3 plus 1. 2 minus radical 3, 2 minus radical 3. And that. The most important idea here is how do we undo this transformation using matrix operations? So the key is inverses. And this is composition. Order matters. We can't just start and do A prime, then B prime, then C prime. Since this is composition, there was more than one transformation at a time, we have to work from the inside out. So we start with the inverse of C to 1 plus 2 radical 3, 2 minus radical 3. When we multiply this inverse by this point, we get 2 radical 3 minus 1 and negative radical 3 minus 2. Next, we take that output and use the inverse of matrix B for the second one. And notice what really happens to these two is what B is supposed to do. X and Y trade places. So our Y, negative radical 3 minus 2, becomes our new X. 2 radical 3 minus 1 becomes our new Y. So those just traded places when we did the inverse, so they traded back. Finally, when we do the inverse of A to the output from the inverse of B, we actually end up at the point negative 2, 4. Now, I actually did these operations in the not the CAS version so that it'll allow computer algebraic systems on the TI Inspire. And that's how I got these exact values. So you might have gotten the same type of calculations using Mathway, but if you're using the numerical version of the TI Inspire, it's just going to give you the ugly decimals, and you have to actually work out how these come together, and you might not get this nice clean point of negative 2, 4. And that's question number 4.